Hello guys, in this video we are going to discuss the solution of the problem next permutation. So let us look at the problem statement. The problem statement says given an array of integers ARR representing a permutation, implement the next permutation that rearranges the number into lexicographically next number permutation. If no such permutation exists, rearrange the number into the lowest possible order, that is sorted in ascending order. So for instance, if this is the array which is given to us, the next permutation will be given by 2, 4, 5, 0, 1 and 7, and that is how we would like the array to be arranged. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say this is the array which is given to us and we need to find the next greater permutation. So in order to find the next greater permutation, what we need to do is we need to keep MSB unchanged, and as many as possible the MSB should be unchanged. So what do I mean by this is, let us say the number which is given to us is 427, and in this we want to find the next permutation which is greater than 427. Now as we can see, there are multiple permutation which is possible over here. So for instance, one permutation could be 724, another could be 742, and then 472, 274 and 247. Now clearly these two permutations are not valid since they are smaller than the current number. Among these three permutations, the next permutation will be given by 472. Please note, 724 and 742 are also a valid permutation, but among these three, 472 is the next greater permutation. And the way we were able to achieve to this is by keeping as many MSBs constant. So for instance, this 4 was kept unchanged, and within these two we have performed some operation in order to come to 472. So our first objective is to find the MSB that needs to be changed. Now let us discuss how we will be able to find the MSB that needs to be changed. So for that, let us take the same example. So let us say this is the array which is given to us. Since we have to find the MSB that needs to be changed, and in order to find the next permutation, we have to keep as many MSB as possible unchanged, the best way to find the MSB would be to iterate from the end of the array. So let us iterate from the end of the array and try to find the MSB that needs to be changed. So right now the number which we have is 0. With single digit number we can't do anything. So the next number or the next permutation with this number will be 0 itself. Now let us proceed forward. Now our iterating counter is at this position. So the number which we have is 50. With 50, the permutation which is possible over here is 0, 5. This is the only permutation which is possible over here. Now since 0, 5 is essentially 5, since 5 is lesser than 50, so this is not a valid permutation, because of which we are going to proceed forward. Now the next number is 750. With 750, the permutations of number which we will get is 0, 5, 7, 0, 75, 570, 507 and 705. Now none of these numbers are greater than 750, because of which we will not be able to get a valid permutation. Because of which, let us proceed forward. Now the next number which we have is 1750. Now as we can see, there are many permutation which is possible over here, but one of the permutation could be given by 7, 1, 5 and 0. Now this number is greater than 1750, because of which we realize that it is possible for us to find the next greater permutation by changing this number. So our first objective, which is to find the MSB that needs to be changed, has been fulfilled. So we understand that by changing this number, we will be able to find our next greater permutation. Now let us try to deduce our logic for this. So as you can see, when the numbers were in increasing order, so over here as you can see, the numbers were in increasing order. This also, the numbers were in increasing order. Since the number were in increasing order, it was not possible for us to find the next greater arrangement or next greater permutation. As soon as this property of the series, which is increasing order property of the series, has been violated, we were able to find a way by which we will be able to arrange the number into greater arrangement. So our logic from here is to find the MSB that needs to be changed. All we have to do is find the number which violates the property of ascending order. So what do I mean by this is these numbers were arranged in ascending order, these numbers. As soon as we encountered a number which violates the property of ascending order, we realize that this is the number which needs to be changed in order to find the next greater permutation. So far we have found the MSB that needs to be changed, and in our case the MSB that needs to be changed is this MSB. So what does it simply mean is our array ARR 2 4 will be unchanged. So this 2 4 will remain as it is. Now 1750 needs to be arranged in certain way in order to find the next greater arrangement. Now let us see how we will be able to arrange 1750 in order to find the next greater permutation. So to do that, we know that this 1 has to be replaced. Now we have an option to replace this 1 by either 7 or 5 or 0. Now let us do that. So let us say we replace 1 by 0. So now this becomes 0, 7, 5, and this value becomes 1. So we are essentially swapping the numbers. So now let us swap 1 and 7. So if we swap 1 and 7, then the number becomes 7 1 and then followed by either 5 0 or 0 5. So this could be, so let me write it down like this. This could be 5 0 or 0 comma 5. Similarly, if we swap 1 and 5, then 5 will come over here, 1 will come at this position and these two places, and within these two places it could be either 7 comma 0 or 0 comma 7. So these are the permutations which we have. Now as we can clearly see that this is not a valid permutation, because this permutation or this number 0751 is lesser than 1750, because of which we are going to discard it. Or we can formalize that, which is if we swap MSB with the number lesser than the MSB, then the overall number will be reduced. And that's exactly what is happening. So this number 1, if this is being swapped by a number which is lesser than 1, then the overall number reduces, because of which this is not going to give us the valid permutation. So that leaves us with the option of either swapping it with 7 or swapping it with 5. Now as we can see, if we swap it by 7 or by 5, the number becomes greater than the current number, but the next greater number will be given by if we swap it by 5. So essentially among these two we have to choose the minimum number. So the way we will be able to formalize this is, in order to find the next greater number, we need to find a number which is greater than the current MSB but least among such. So what do I mean by this is the numbers which are greater than 1. So the numbers which are greater than 1 are 7 and 5. Of these two numbers, the number which is going to give us our answer is this number. So this 5 is greater than the MSB, but among these two, this is the least number. So we need to find the first number which is greater than MSB. And how do we find such a number? So folks, please note that this number is already arranged in increasing order. So this is already in ascending order. So in order to find such a number, all we have to do is we need to find the first number which is greater than MSB. And that will give us the number with which MSB needs to be swapped. So now we know with which number the MSB has to be swapped. So folks, the number which we had is 1750, and we understand that this 1 has to be swapped with 5. So let us swap 1 and 5. So after swapping 1 and 5, the number we will get is 5, 7, 1 and 0. Now since we have to find the next greater number, so the next greater number can be found if we arrange this number properly. And the way we will be able to arrange this number is 5 0, 1 and 7. So folks, what we are doing is we are just reversing the number. And the reason why we are reversing this number in order to get our next permutation is because, folks, if you see, this number was in ascending order. So let us say if this is the number and we have to arrange this number such that we get the least number, all we have to do is we just have to reverse this number 057. And that's exactly what we are doing over here. So that's the overall idea behind solving this problem, folks. Now let us do a quick recap in order to understand this solution. So first, what we would like to do is we would like to find out the MSB that needs to be changed. And the way we will be able to find out is we need to find the first number from last which violates the property of ascending order. And once we have found out the MSB that needs to be changed, we need to swap that MSB with the number which is greater than the current number. So swap the MSB with the first number which is greater than the current MSB. And after that, all we have to do is we just have to reverse the numbers from MSB plus 1 index to end of array. And in this way, we will be able to find the next permutation which is greater than the current permutation. So, for instance, if this is the number which is given to us, so in this number, first we would like to find the MSB which needs to be changed. So for that, we just have to find the first number which violates the property of ascending order. So from here, as we can see, 0, 5 and 7 are in ascending order. The first number which violates the property of ascending order is 1. So this 1 has to be changed. Now 1 has to be changed with which number? So within these numbers, we have to find the first number which is greater than the MSB. So the first number which is greater than MSB is 5. So 1 and 5 needs to be swapped. After swapping, the array will look something like this: 2, 4, 5, 7, 1 and 0. And after that, all we have to do is, which is the final step, is to reverse this portion of the array. So let us reverse that. So ARR finally will become 2, 4, 5, 0, 1 and 7. And in this way, we will be able to find the next permutation which is greater than the current permutation. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to find the next permutation and an array is given to us. So for this, we want to find the index or the MSB that needs to be changed. Let us call that index or the MSB index as pivot, and the pivot will be given by, and this function returns the MSB that needs to be changed. Now the first thing which we will do is we will check whether pivot is not equals to -1. So in the case where all the numbers are arranged in increasing order, then in such case it is not possible to find the next permutation. So the pivot will be -1. So in such case, all we have to do as per our question is we just have to reverse the array. So we are going to reverse the array ARR from 0 to len of array -1. So essentially we are reversing the entire array. The starting index is 0 and the end index is len of ARR -1. And from here we can just simply return. If let us say pivot is not equals to -1, then we have to find the first number which is greater than the pivot element. So let us do that. So let us say the index of that number will be given by index, and find greater is that function which finds the first number which is greater than the pivot number. So for that, ARR and pivot will be passed to find greater function. Once we have done that, then all we have to do is we have to swap pivot and index elements. So for that, temp equals to ARR index equals to ARR pivot, and ARR pivot equals to temp. And in this way, we will be able to swap the numbers. After swapping the numbers, all we have to do is we just have to reverse the array. For that, ARR and what all indexes that needs to be reversed. So the index starts from pivot plus 1 all the way till end of the array. And in this way, we will be able to arrange the array in such a way that it gives us the next greater permutation. Now let us look at these functions, which is return pivot, reverse array, and find greater function. So first let us look at return pivot function. So to this function, array was given to us, and we need to find the number which breaks or which violates the property of ascending order. So for that, I is equals to len of array minus 2, and then all we have to do is while I is greater than equals to 0, and if this number, so arr I, is less than arr I plus 1, which simply means it is not arranged in ascending order, then in such case all we have to do is we just have to return I. So this is the index which violates the property of ascending order. Otherwise, let us decrease our I by 1. And let us say the array did not violate the property of ascending order at any time, then in such case we are going to return minus 1. And in this way, we will be able to return the pivot index. After that, now let us look at this function which is going to give me the first element which is greater than the pivot element. So let us look at this function, find greater, array is given to us and the pivot index. So for this, all we have to do is we have to set I is equals to len of array minus 1, and then we have to iterate on I while I is greater than pivot. So the first number which is greater than the pivot is what we need to find out. And then all we have to do is we have to check if arri is greater than arr pivot. If this is the case, so this is the first number which is greater than arr pivot, because of which we are going to return I. Otherwise, let's decrease our I by 1. And if this condition is not satisfied, then we are going to return minus 1. And in this way, we will be able to find the first number which is greater than the pivot element. Now finally, let us look at the reverse function. So for this, an array is given to us. Its starting and ending index is also given to us. And in this, all we have to do is while start is less than end, let us swap start and end. So temp equals to arr start equals to arr end equals to temp, and after that let us increase our start by 1 and decrease our end by 1, and in this way we will be able to arrange the array. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. First we have found out the pivot element. If pivot equals to minus 1, then we are reversing the entire array. Otherwise, we are finding the first element which is greater than the pivot. We are swapping pivot and index element, and then we are reversing pivot to end of the array. Now let us look at the functions. So first let us look at the reverse function. So for that, while start is less than end, we are swapping start and end, and then we are increasing and decreasing start and end pointer. In the return pivot function, I is equals to len of array minus 2, I is greater than or equals to 0. If this is the element which violates the property of ascending order, then we are returning I. Otherwise, we are returning minus 1. And in the find greater function, we are looking for the first element which is greater than the pivot element, and we are returning the index of that number. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So the C++ implementation is also the same, folks. First we are finding out the pivot element. If this is equals to minus 1, then we are reversing the entire array and returning from there. Otherwise, we are finding the first element which is greater than the pivot element. We are swapping pivot and index element, and then we are reversing the array, and the elements which are getting reversed are pivot plus 1 to end of the array. In the reverse array function, while start is less than end, we are swapping start and end, then we are increasing and decreasing start and end. In the return pivot function, if this element violates the property of ascending order, then we are returning that element. Otherwise, we will return minus 1. And in find greater function, if the current element is greater than the pivot element, then we are returning the index of that element. Otherwise, we'll return -1. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ implementation also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.